from our section on graphs, we've seen that whenever you get given 2 points, you can always come up with an equation for a straight line. So the first thing you would do is the first thing you would do is to write down y equals mx plus c, and then you got to find out the gradient. Well, the gradient would be the up and down here, so it would be this take away this. So the gradient would be the up and down, so that would be 6 take away 3, and then divided by the across here, so that would be 7 take away 2. So that would then give you your gradient. So we've seen this in our section on graphs. So now let's apply it to this situation here. So looking at this diagram from the previous video here. Okay, in the previous video, we've seen that if you know the derivative at one particular point and you know it passes a particular point, you can always come up with an equation for a straight line here, which was given by this. But this is a bit hard to remember. So let's look at this here. Let's look at this diagram here. So whenever you have a function f of x here, a straight line function f of x here, so the derivative is this, and it passes through this point here. So remember, so looking at this diagram, the gradient which is given by this, the derivative, the gradient is, so what you do is you look at the diagram, set up one point here. So this point here, it could be anywhere on this line here. It could be over here, it could be up here. So starting out with this diagram, we're going to somehow get to our equation here, because this is quite hard to remember here. Okay, so hang on. So looking at this diagram here, set up one point. Remember, this point could be anywhere. So let's call this point x, comma y here. So the coordinates of this point here is x, comma y. This here is fixed. It's one particular point. This here, it can move about. Well, it doesn't matter where. Let's just call it x and y. So the gradient. So normally we would want the up and down divided by the across here. Well, the up and down here will be given by, well, the gradient. This is our derivative. The gradient is equal to, now the up and down, which is this thing here, take away this here, that's this here, divided by the across. Well, the across will be this x here, take away this here. That will then give you your across. Basically, looking at this diagram, set up your point here, x, comma y here. Okay, so the gradient would be this height here, which is given by this, divided by the across here, which is given by this. Okay, so now look. Well, imagine this as being a bubble here. Multiply this bubble to both sides. That will then give you this. Okay, and then you try and get y on its own. So add f of x 0 to both sides. So that will then give you this. So the equation is given by this here is our equation here. Y equals well, this is our equation. It's y equals, in a way, mx plus c. This is our equation here. This is exactly the same as up here, but just written differently. Okay, so well, this here is a bit hard to remember. So start out with your diagram. Start out with your diagram here like this, and then just know that, well, the gradient, which is y prime of x0 here, is given by the height. Well, you would set up your points here, x, comma y here, and then just get this divided by this. That would equal this, and then rearrange it to get y. Rearrange it to get y on its own. Okay, so yeah, so follow it through. And by the way, it doesn't matter if you set up your point over on this side here. So if you set up your point over on this side here, well, the gradient here, well, it doesn't matter if you set it up over here, because you would just get the height here. The height here is given by this, take away this point here. Okay, and then divided by the across. The across here would be this here, take away x here. It's just more awkward, that's all. And then rearrange it to make y here the subject. So here, so when you're here, multiply both sides by this bubble here. That will then give you this. Okay, and keep an eye on y. You're trying to make y the subject here, but at the moment it's negative. So add y to both sides. That will then give you this. Okay, and then take away this block from both sides. So that will then give you this. So now y equals this. But you're not familiar with. Normally you're familiar with x take away x0 here. But at the moment it's this here is 0, x0 take away x. You're unfamiliar with this. So, okay, if you're unfamiliar with it, multiply both sides, multiply this out. So it's like this. Okay, so that would give you a minus block plus this thing here. And now, now switch these two around. So this one goes in front and this one here goes behind. So that will then give you this. Now you can factorize. When you factorize, it will get you into a form that you would recognize. X take away x0 here. The point here is that the point here, the equation of a straight line is given by this here. Okay, but if you can't if you find it hard to remember this, then start with the diagram. Start with the diagram, but don't set it. You can set it up over here, but don't set it up somewhere up here. So use this one up here. Okay, so start out with your diagram like this. So, well, the equation of a straight line is given by this, but this is really hard to remember. So start out with your diagram. Start out with your diagram like this. Okay, and then set up one point. At this point, it could be anywhere. Let's just say x comma y here, and then you know that the derivative, the gradient is this height, which is this, divided by this, and then rearrange it to make this y the subject here. Okay. Well, anyway, just remember that the equation of a straight line is given by this here. Okay. This here, yeah, that's the equation of a straight line.